Right. So welcome back to your favorite inorganic Twitter YouTube channel. Um, Today is another episode. We want to look at how we can calculate a value for a limit when you are given a question, right? But I understand the course is very rough. Um, it's some way ununderstandable, but please calm down, calm down. We are going to use graphs, we use values, and then just some another kind of explanation, and then you get it right from here. So let's look at how we can tackle this particular problem that we have right here. 2x plus 1 as s approaches 4. This right here. So this right here, you know that when you use direct substitution, you're going to have the answer, right? But this is where mathematicians will come in and ask you, how did you get, or how do you know that this right here is correct? And that is where epsilon delta definition comes in, right? And that is very confusing, but we'll make it so easy right here for everyone to understand. Using epsilon delta is not difficult at all, but you just have to calm down and focus on the course, right? So this right here, when we do direct substitution, we are going to have this right here, we are going to have 2 into 4 plus 1. And that right here is equal to 8 plus 1, which is equal to root of 9, and that is 3, right? So we have this right here to be 3, right? And a mathematician will challenge you that, how sure are you that this value is 3 when s is approaching 4 is 3? Well, I want to use the epsilon delta approach. But first, I will start with some graphical representation for you to get it well, right? So this right here means that, this right here we have as 3 means that, this means that for all values, epsilon must be greater than 0. So this means that for all values, epsilon must be greater than 0, right? Such that, or there should exist delta. So this definition is just some definition that you have to know. For all values of epsilon greater than 0, there should exist delta that is also greater than 0, right? And that should fall within a particular range, right? So in that case, you have to suppose the function. So this right here is going to be 0 less than x minus 4, which is as what the number is approaching, right? So this normally we name it a, which is the a. So x minus 4, right, should be less than delta, right? So whenever this is true, then we are going to have this right here as the function, which is 2x, square root of 2x plus 1 minus the limit that we said is 3, right? And that should be less than delta, epsilon. So let me take it again. This statement we have right here, square root of 2x plus 1 equals 3, means that for all values of epsilon should be greater than 0, right? There should exist delta also greater than 0. And then we can say that if this is true, then whenever 0 is less than x minus 4, then it should be less than delta as well. So, right? So that we have right here, you can see, right? So this, let me represent it using the graphical approach for you to get it right. So we have right here our graph. So let's draw the square root, right? The square, right? So we have right here our square in here, right? And first S is what? 3, right? So let's assume that it increases by 0.02, 0.02. So we have right here 3.2, and then it decreases by 0.2 again. So we have 2.8 right here, right? So if this the limit should increase by 0.2, then we have here 0.3, right? 3.2, right? So if all that I say is that let epsilon equals 0.2, right? So if epsilon equals 0.2, then we can say that 3 plus 0.2, and that's 3.2, right? And it should decrease by 0.2, and that's 2.2 right here. So if we are to draw the graph, then let's also assume that if this right here is y equals something, right? So if we have s to be 3.2, then we can say that the y is also 3.42. When you put in this limit, don't worry, I have the values right here. When you put in 3.2, then we are going to have 3.42, right? And that is right here. When you put in the 2.2, the 2.8, you are going to have the 3.42, right? And then when we also choose another value, so this is the 4, right? S is approaching 4. So that is what we have right here, right? And then let's choose another value, right? So the 3.2, right? So when you take the 3.2, that means when you put 3.2 in right here, you are going to have this 4.62, right? So we take this up, and then we have this right here. Very, very simple. Calm down, right? So we can see that when we trace it, we can see that this right here is within epsilon. This right here is within epsilon. This 3.42 is within epsilon. The more you close this one, you can see that you are coming close to epsilon, right? Right? You can see that you are closing to epsilon, right? So we say that when you find the difference between these two numbers, 4 minus 3.42, you are going to have 0.58, right? And when you find the difference between these two numbers, you are going to also have 0.62, right? So we choose the smallest number, right? So when you choose this, the smallest number for between these two, we can say that we can choose 0.58. So we can say that delta is equal to 0.58. Well, this is just a graphical representation, right? So don't be scared about this, because you can see that right here, the more we get close to epsilon, it closes the gap, right? So it's very simple. Just get it right from here. So we can see that delta is 0.58. Delta is 0.58 using the graphical representation. So now let's use the epsilon delta approach, the epsilon delta proof to derive this solution, right? right? So this right here, we can see that uh, since delta is what given in every epsilon delta proof, you have to write this English. If you don't have this English, you are not proving for epsilon delta, right? So we have epsilon should be greater than 0. There should exist delta that is also greater than 0, right? Or we can say that if epsilon is greater than 0, there should exist delta, right? There should exist delta, right? So we say delta should be equal to a number, right? So we choose delta. But this right here, we can say that we are going to choose delta. Well, you can say that delta is 0.000000001. But if you do this, your lecturer might get mad at you because how proof or how sure are you? So that is when the proof comes in, right? So we suppose 0 is less than the function minus the limit, right? So we have 2x plus 1 minus 3 should also lie between should be less than delta, right? So we assume, epsilon is the distance between the function and then the limits, right? So we assume that 0 will be between these numbers, right? So we say that we have to check what we are doing. We have to check. So we say check, right? So we say absolute square root of 2x plus 1 minus 3, right? This right here, what we have to do is that we have to use rationalization to manipulate this so that we can find our delta, right? So when you rationalize this, you are going to have square root of 2x plus 1 minus 3, then all over square root of 2x plus 1 minus 3. Rationalization now here tends to positive. Then square root of 2x plus 1 minus 3, right? So this right here we have here, this is positive, right? We just want to manipulate the function so that the function and the limit so that we can find our delta. So this right here, when you simplify, then we are going to have 2x minus 8 all over. When you simplify this numerator, you're going to have 2x minus 8 all over square root of 2x plus 1 minus plus 3, right? Or absolute. And this right here is the same as 2x minus 8 absolute all over square root of 2x plus 1 plus 3. This right here means that the number will be positive because it's under a square root sign. So whether you add the absolute or you don't add it, it will still be a positive number because it is under a square root sign. And we assume that any number under or that is under a square root sign should be a positive number. Other than that, we have a complex function, right? So this right here, we can say that this is equal to 2 into x minus 4 absolute all over 2x plus 1, the square root of that, plus 3. And this right here is 2 delta, right? So we have this right here is equal to 2 delta, right? And this right here, we can consider it as nothing because we have square root of 2x plus 1 plus 3, right? We can assume any number when we put it inside. This right here is going to be 1, right? So we forget about that one, and then we can see that this is equal to 2 delta. So what number can we divide with this thing so that we can have delta? So that we can say that delta is equal to epsilon over 2, right? So we can say that epsilon right here is dividing 2, right? So we can say the proof has ended. We can say we have delta equals epsilon over 2. And that is it. Very, very simple. You know, in epsilon delta definition proof, what you have to do is that you have to choose a number. Most times, you can choose a number for delta, but your lecturer might get mad at you. So that is why we go through this process to land at a particular answer, right? So it is very simple. Thank you very much for watching. I really appreciate your time. Bye.